Hi, and welcome to Axelbank Reports History and Today. Conversations with America's top nonfiction authors and why their books matter right now. I'm Evan Axelbank, and today we're going to speak with Dr. Kyle Harper, the author of Plagues Upon the Earth, Disease and the Course of Human History. This is his fourth book. He's a professor at the University of Oklahoma, where he is a professor of classics and letters, and is also a senior advisor to the president there. He's a historian of ancient Rome and early Christianity as well. Thanks so much for being here, Dr. Harper.
Hi, Evan. Thanks for having me.
Before we start our interview, I want to invite listeners to our Patreon page to ask for your support in keeping the show going. Go to patreon.com/AxelbankHistory. We will donate part of your contributions to a charity for children's literacy. On New Year's Eve, 2019, the first article was published on COVID-19, where the term pneumonia was used. It was spreading in China, and doctors were watching. In 2 years, more than 800,000 Americans and 5 million worldwide have died. The economy has changed. How people work has changed. COVID-19 has impacted families, migration, fear, and politics. Clothing, transportation, technology, food, faces, even exercise. It's all different. COVID has changed the planet. It's easy to say we're living through, quote, unprecedented times, but Dr. Harper, is use of the word unprecedented correct?
Well, the professor in me wants to say define unprecedented. I'm a historian of infectious disease, and so I study the role that infectious diseases have played in the human past, and I really deeply believe that we need to learn from this history, and that infectious diseases have constantly played a role in shaping human societies. And so epidemics are more like a constant than an anomaly. Everyone's different, and COVID-19, of course, has many features that make it distinct from the episodes of sudden mass sickness and mortality that human societies have faced in the past. But no, I mean, I tend to see this as a kind of part of the continuous stream of history. And as a historian, just leaving aside the amazing expertise in public health and microbiology that told us this was going to happen, as a historian, I also think that this was completely foreseeable and that we were really complacent in somehow not being more prepared for it.
What's fascinating about this book is, first of all, it's a beautiful book, and it is produced beautifully by Princeton University Press. But what's interesting is you are a historian of infectious diseases. So before we even get into the book, I want to ask what your, and don't take this the wrong way, what are your qualifications to discuss disease? Are you a historian in the classical sense? Do you have a medical background? Do you have a little bit of both? In other words, I guess I would also ask, what's a professor of classics and letters doing writing about this?
Well, my 11-year-old daughter has introduced me as a doctor, but not the kind that helps people. So I'm not a medical doctor. I have a PhD in history. I'm trained as a historian, and my expertise is in the history of the Roman Empire. And before I wrote this book, my last book that appeared in 2017 was a study of the environmental history of the Roman Empire, and particularly the experience that the Romans had with pandemic disease, because it's very apparent from the sources that we have, that we know about the Roman Empire from, that the Romans lived through these absolutely massive mortality shocks where unfamiliar diseases suddenly appeared and swept over their empire and killed tens of millions of people. And so to me, that was kind of a hook. I mean, it's such a fascinating part of the human past. And I got really into the ways that we can only really begin to understand those episodes from the past with different tools. And so historians are trained in language and interpretation of documents and explaining patterns of social change. But how do you do that? How do you explain change if a big agent of change, not the only one, but a really big one, are invisible pathogenic microbes like the germ, the bacterium that causes bubonic plague, which is one of the really big factors in human history. So I fundamentally believe that the best history is interdisciplinary, and that it's trying to bring the tools and insights from other fields, whether that's economics, whether that's microbiology, to understand the human past more deeply. So historians are kind of a unique discipline because we have to be able to converse with scientists and scholars in very different fields. And I've been fortunate to have a lot of mentorship and friendship that hopefully allows me to have conversations with microbiologists and bring some of their insights into the knowledge of the human past.
Your introduction to the book made me see the beginning of my day in a whole new way. And it was just the way you broke it all down piece by piece. You say we clean ourselves in so many different ways. You described light disinfectants, including 2-ply tree products, a jelly loaded with aluminum compound to waylay the I don't even know how to say this word, waylay the malodorous bacteria in our underarms.
Smelly.
Smelly is the word. What we are doing is trying to defy the nastiness that can make us sick. And you say the privilege to do that captures our lives in this modern world. Even if we know we're going to die one day, we're trying to delay that day. And it won't be because you say in the modern times, because we caught something like a pox or a plague. Should we call that modern privilege, that we seem to be safe from poxes and plagues?
Absolutely it is. And I mean, this is one of the powerful things that history can do. It can help us see ourselves more clearly, and it can help us realize that things we may take for granted about the way we live, the expectations we have, our routines and habits, and our physical environments, our domestic environments, all of those are a product of history. They change. And the way we live now is very exceptional in historical terms. Germs have sort of held the upper hand over humans for 99% of our past. If you think about the big picture, humans have existed for 200 to 300,000 years. And it was only about a century ago that we were able to control infectious disease to the point that most people died of something else, of chronic disease, of organ disease, of degenerative disease. So most people, most of the time, for nearly all of our past, died of infectious disease, whether it was in big plagues like bubonic plague or smallpox, or whether it was just kind of the constant endemic battle with diseases like tuberculosis, which is one of the great killers in human history. But most people died of germs. So it's a really revolutionary moment when humans, through a whole array of inventions and biomedical tools, are able to change that, and we get the upper hand. And we're pretty forgetful. I mean, I think most people don't really reflect on the fact that it's only been 3 or 4 generations that humans have had the privilege to live like this. And as you were saying, it does still shape our routines and lives, and the way we eat and clean ourselves and maintain our physical environments, and the world beyond are all really powerfully shaped by the need to keep our germs at bay.
Most of us are not scientists, but your book really does a great job at breaking stuff down. Why did you want to write this? Why did this need to be written for the common person?
Well, as I mentioned, I finished my last book in 2017, and I wanted to write a book about disease because I didn't understand where did the Roman experience fit into the bigger picture. And so I kind of wanted to know, how was the Roman experience similar or different from other societies? Where did it fit in the big picture? Why did the Romans get these diseases? Why then in human history? So I really wanted to write this bigger global history that goes back to the very beginning and then takes the story right down to the present. Of course, I had no idea that COVID was going to happen in the course of writing the book.
Right, you started this 4 years ago?
Yeah, I started it 4 years ago.
It just kind of happened.
But it's kind of surreal. And the book was originally framed as a warning, and had to rewrite some of the introduction that sort of was framed as trying to sound the alarm from a historian's perspective that we should be mindful of the reality that nature doesn't stand still because evolution doesn't stop. And the way we relate to the natural environment means that there's going to be a dangerous new pandemic. So I wanted to write the book because I thought it would be a good warning, and history has a power to connect with people. And people love to understand the past and how we got here. And so I thought it would be a way to communicate the ongoing risks. But of course, then COVID-19 kind of scooped that.
Baking from our childhoods just sticks in the memory, doesn't it? We never set off on holiday without piles of Tupperware. And there'd always be Bakewell slice, flapjacks, and tray baked scones in the boot.
Do you not do that, Lisa?
Yeah, no. Sadly, I do not stack the Tupperware in the back of the car when we go off on holiday.
Oh.
Welcome to Small Ways to Live Well, a new podcast from the Simple Things magazine. Season 2 is a pick-me-up tonic that helps us make the shift from winter to spring. A 6-week suggestion box full of things to note, notice and enjoy about the season. Search for Small Ways to Live Well on your podcast app.
I'm curious about your sources. Disease, as you say in the book, has been here essentially forever, but pens and paper haven't. So how difficult of a topic was this to study for you, going back to, ancient Rome and all the other times in history where pen and paper were not necessarily available?
Well, I mean, I think it's worth underscoring the obvious, which is just the further back you go, the harder it can get to know what diseases people actually died from. Really sophisticated efforts to measure by cause mortality, so like the importance of all the different diseases that kill people, only go back to the early 1990s. So thinking at a global level, if you just want to ask the question, what diseases make people sick and kill people, there are only really sophisticated quantitative efforts to do that for one generation. You go back a little further, there's only good government data from even the most advanced governmental systems, like in Britain and the US, collecting really good by cause data. In the US, it only goes back to about 1900. And when you go back earlier than that, you're really estimating or guessing what diseases killed people. You go back further, they don't even know there are germs. So they don't think of disease as a condition that might be caused by the invasion by a particular species of bacterium or virus. So the further back you go, the harder it is even to understand the sources and what they're saying, because their scientific worldview is very, very different from ours. So it gets harder and harder. Then, as you say, you go back to prehistory where there isn't anybody writing anything, and you have to use only archaeology. But this is where I think we're very lucky as historians. At this moment, there's a lot going on that's giving us new ways to kind of do what one group of scientists have called time travel. And one of the really cool ones is archaeological DNA. This is the sequencing of the actual DNA of the germs that killed people, sometimes thousands and thousands of years ago, where we would otherwise really have no idea what was there and what killed them. It's like amazing courtroom evidence. Like you have this DNA proof that this germ killed this person in this archaeological context from, say, the Bronze Age. And that's really revolutionary for historians. And it's one of the ways that the sciences are helping us to get over the lack of kind of traditional evidence.
Did you consult with a lot of scientists as you wrote the book?
Yeah, I mean, I've been lucky to have the opportunity to learn from a lot of amazing people who are doing all sorts of different relevant work, from genome sequencing to archaeological DNA. And then also I'm lucky to have friends who are practicing physicians, and one of my best friends read every word of the manuscript kind of with
lucky
a
him.
medical doctor perspective on it. And it really does make a huge difference to have the opportunity to work with experts in other fields, or have them generously help make your work better.
There's an interesting contrast that you write in the book, and maybe it's just a play on words, but you call it microorganisms and macro history. When and how did you decide that contrast, that turn of phrase, defines human civilization?
Well, actually, I was struggling with the title of the book, and I gave a seminar at OU, and I want to give a shout out where it's due. One of my colleagues here in the philosophy department, Zev Trachtenberg, said, what your book's really about is microorganisms and macro history, and that's dead on. I couldn't use it for the title of the book. It's a little, I don't know, it's a little too cute, but I did use it for the introduction because I think it tries to capture where I'm coming from and what I'm trying to do, which is macro history. So to talk about what are the really big patterns of human history, and then explaining some of those patterns and how they relate to microorganisms, to bacteria, viruses, fungi, and protozoa that cause human disease.
So one of the I guess sub plays on words that you have in here is our germs make our history, but our history makes our germs. I guess it's sort of obvious how germs might make our history. We're living through a time right now where history is changing by COVID, or being changed by COVID-19. How does our history make our germs? What does that mean? And give us an example of how our history makes our germs.
Yeah, great question. And that's really the central theme of the book. And I try to look at humans the way somehow from the outside. So recognize that we're an animal. We have pathogens and parasites like any other animal. And I think that can help us see how strange we are. If you compare us to our closest living relatives in the animal kingdom, chimpanzees, chimps have a lot of diseases, a lot of infectious diseases. They have a lot of germs relative to other animals, but they have nothing compared to our disease pool, which is much bigger, more dangerous, and full of germs that are really narrowly specialized in infecting the human body. So the question is, why is the human disease pool so weird? Why do we have so many germs? Why do so many of them cause such virulent disease? Why do so many of our pathogens take the kind of evolutionary gamble to only be able to infect one species of host, us? And the answer is, in one word, is history. It's all the things that make us different from chimps. Chimps don't have history. They're smart. They have some tool use, but chimps today live almost exactly the same way chimps lived 100,000 years ago. They live in the same spot, equatorial forests. They eat the same foods, fruits mainly, but ants and occasionally a little monkey here and there. They use the same tools. There isn't cumulative technological cultural change. Humans, so chimps live the same, and they have pretty much the same diseases, or at least the same profile of diseases. Probably been some evolution, some come, some go for sure. But humans are very different. We live very, very different than our ancestors did 100,000 years ago because of culture and technology. And every time we change the way we live, it stimulates an evolutionary response from all of our pathogens or potential pathogens. So we live completely differently than our ancestors did 100,000 years ago. And we have a very different disease pool. So one thing we've really learned is that diseases like malaria, tuberculosis, smallpox, measles, these are not really, really ancient diseases. They were not there in prehistory. They really are a product of human growth, the expansion across the globe, domestication of animals, the formation of cities and empires and trading networks and so on. So that expansion and growth and progress that the human species has made is paradoxically the driving force behind the creation of our disease pool.
Are we able to pinpoint the earliest time a major outbreak of infectious disease changed history?
No, they're there in the very earliest Mesopotamian sources. They're there in the Jewish Bible, the Christian Old Testament, which is a slightly later product of late Bronze or early Iron Age, but still some very early texts. There's lots of plagues there.
Give me something that you can pinpoint. Give me something we can grasp onto and say, this happened in such and such year, and this is how it changed things?
Yeah, I think one of the really first major pandemics that we can really trace from the historical record doesn't happen until the Roman Empire. Now, there's some earlier ones. There's the plague of Thucydides, which hits Athens. We kind of only know really what happened in one city. But the plague that hits the Roman Empire at the very height of the Romans' power and prosperity and population, like everything in the Roman Empire is at its absolute peak under Marcus Aurelius in the 160s. And then, boom, out of nowhere, the Roman Empire is rattled by an epidemic that really is a pandemic. So it's a major sudden outbreak of infectious disease that is pandemic in the sense that it's everywhere. So it's in Africa, it's in the Near East, it's in Europe. There's some possibility that it's even in China simultaneously. It's a really amazing, very intriguing, but still somewhat mysterious episode. One of the kind of, for me, I've spent a lot of time writing about and thinking about this pandemic because it really intersects Roman history. We don't know what caused it. It's very frustrating. We haven't found the genetic material of the pathogen. It may have been an ancestral form of smallpox. I think that's certainly the most likely hypothesis we have, but we also just don't have a lot of good hypotheses because it's very hard to identify what disease this was from the kinds of ancient texts that we have. But whatever it was clearly very deadly and spread very fast and very far. I mean, it's attested at opposite ends of the Roman Empire almost simultaneously. And it really rattles Roman power. I mean, the Roman Empire doesn't fall. It doesn't fall apart. It doesn't pack up and give up. But this is like a turning point. There's never again, is the population that big? Is the economy booming to the same extent? Is urbanism or trade quite as robust at the imperial scale? And never again is the Roman Empire quite so dominant internally and externally over its provinces and its enemies beyond the frontiers. So to me, it's a really interesting episode. And kind of exactly as you're saying, one of the many reasons why it's cool is just, this is almost 2,000 years ago. It's one of the first times we can really trace an event like this that we know had happened before, but we can trace it from human testimony.
We are currently living through COVID-19, as we all know, and there are conspiracy theories that have come up about COVID-19. For instance, it was started by the Chinese government. It was let out by the Chinese government. It was a mutation that got loose in a lab. It was a mutation that was purposely made and infected with somebody. And we really just have not been able, as you said, to pin down exactly what caused the first case of COVID-19. And we may never know. What is the earliest, or what are some other examples of conspiracy theories that have cropped up when it comes to infectious diseases? I'm sure someone's always been blamed unfairly for them.
Oh, absolutely. I mean, as a historian, first of all, I'm very much for being open-minded about trying to explore the origins of COVID-19. It's not impossible that either it was genetically modified in a lab or that it was being studied in the Wuhan Institute for Virology and accidentally released. So I'm very much for open-mindedness. I think that's the way science progresses. With that said, I seriously doubt that it was either engineered in a lab or released accidentally from a lab. And I think there's a lot of good reasons why people whose views I trust doubt that. I actually think we will keep getting better and better evidence that it was a natural crossover event. And one thing that you're always influenced by your sort of the way you see the world, sort of your day-to-day things that you study. And so as a historian, one thing I study is where human diseases come from. And they come from wild animals. And we knew that coronaviruses in particular were one of the most serious threats to do this. This wasn't like a a case of, wow, we could have never guessed that, or how did that happen? Never saw that coming. No, this is exactly where we were told to look. I mean, influenza is an ongoing risk for a genetic mutated strain that could cause very severe disease and spread very easily in human populations. But coronaviruses are right there near the top of what we expected to be the biggest risk factor. So when you study, when you sort of study where diseases come from day to day, it doesn't mean that it couldn't be engineered, that could happen. But it also means that you're sort of attuned to recognize that this is part of a very, very deep pattern with other coronaviruses, with every other kind of virus and bacteria that infects humans. But also, as a student of history, you see that there's often a very disturbing tendency to blame others when pandemics happen. And so from ancient times to medieval times, this is almost a constant in the case of epidemic disease. When the Black Death happens in the 1340s, which is one of and probably the worst mortality crisis at a continental scale, there are all sorts of different scapegoats, but one of the really most quickly spreading conspiracy theories is that in Europe is that Jews had intentionally infected others with the disease, and this manifests directly in incidents of violence against Jews in the late Middle Ages. So this goes on, I mean, right down to the present. So it also, you're sort of attuned to realize that there's something about the human mind, unfortunately, that wants to find and blame a person. And I think, again, that doesn't necessarily mean that that's not what happened in this case, but it sort of sensitizes you to realize that people have always said that, and so far they've always been wrong.
There are 4 ways that you say diseases start to transform in terms of advances made by human civilization and how that then impacts disease. You have fire, farming, travel. You put it, the hemispheres are reconnected nowadays, right? Because of the way we can travel. And then fuel. Just describe a little bit of each there and why we all need to be aware of how those 4 pillars of human society began to transform the diseases we were exposed to.
Well, it's meant to be helpful in trying to organize all of human history. So we're talking about this giant story, this long journey that our species has made from our origins in Central or East Africa 200 to 300,000 years ago down to our super connected social media, jet travel, CRISPR, quantum physics world that we live in today. So I think one of the really powerful driving forces in human history is technological change. And it happened more slowly in the past, but it was the development of new technologies that empowered human societies that sort of is one of the motors of human history. So going back, even before we're actually Homo sapiens, fire is in some ways like the source of all technology. It's the thing that makes us different. It's not even developed or controlled, I should say, by humans, but rather our ancestor Homo erectus, who was a pretty amazing, big-brained hominin, so an early human, and somehow figures out that you can control this thing, and you can use it to cook, to burn things, to build things, and that's sort of like the first great technology, and in some ways is one of the things that sets our ancestors on a separate evolutionary path, but also changes the way we relate to nature, including health and disease. Farming is up there. I mean, these are trying to get at like what are the really, really biggest changes in the way we live, and the transition in our history from a time when every human on the planet was a hunter-gatherer. So you had to take your food from wild sources, whether you killed an animal or harvested a wild plant. Farming is like in some ways arguably the greatest change in the way humans have lived. And it changed everything about the way we relate to nature and was a really important transition in the history of human health and disease. I like alliteration. So the third one I call frontiers, but I wouldn't say this is maybe on the same par as the others, but it's still up there as humans learn more and more to travel over oceans. Indian Ocean travel is very ancient, but Atlantic and then Pacific travel are modern. And Atlantic and Pacific travel reunite the old world and the new world, which has all sorts of important and strange and unintended consequences for life. And one of them is the exchange of diseases between the old world and the new world. That really is one of the big moments in the big story of human disease. And then fossil fuels. I mean, our modern society depends on industrialization and rapid technological growth that moves most of us off the farm and into factories and cities. And all of that is ultimately dependent on energy and getting energy from something other than living plants. And the only other place you can easily get energy in 1800 is from fossil fuels. So coal, and then eventually petroleum and gas really are the basis of modern society. So I'm trying to tell this long story of this really big journey that our species takes. And you could organize it different ways, but technology seems as good as any of them to me.
As you mentioned, diseases essentially ran, I don't want to say uncontrolled, but for a lot of human history, we were really at the mercy of microbes. The giants of disease fighting, Darwin and Lister, start to come up with their theories, which turn out to change the entire civilization, the entire species. What was colliding I always think of poor President Garfield, right, who was infected and then reinfected after he was shot. And doctors had no idea. Well, some of the doctors did know what to do and some of them didn't. And he wound up dead because of these terrible infections that he got. What was colliding historically that made their discoveries possible, Darwin and Lister?
Well, I think, first of all, the human control that we've gained over infectious disease is one of the most important stories in our past. And it really wasn't, as I was saying, that long ago that average life expectancy was 20 or 30. Most people, most of the time, died of infectious disease. Most parents buried children. A minority of humans ever lived to see their potential. And the basic reason why human life expectancies have more than doubled and almost tripled around the world, even in societies today with the lowest per capita life expectancy, they're more than double what they were a century ago. So there's still important progress to be made, but everywhere on planet Earth, human societies have benefited from the prolongation of human life that's been achieved by controlling infectious disease. So how did that happen? It's not a simple story, but one thing I do is I actually try to move it back a little bit to the 18th century. Sometimes we start a little bit late, and so it makes these scientists of the 19th century, others that you didn't mention that are really important are Louis Pasteur or Robert Koch as well. They just sort of show up and discover germs, and then everything gets better.
Everything's good.
Actually, there's a lot going on globally and even in Western Europe in the 18th century, the Age of Enlightenment, when people start looking at nature and saying, we shouldn't trust dogma or the classics or inherited tradition. We should experiment, and that's really revolutionary and starts to give human societies in Western Europe the sense that it would be possible to prevent infectious disease. And so even before they really understand germs, they're doing things, experimenting with ways to prevent disease that start to prolong human life. And that's how vaccination is discovered. In 1798, the English physician Edward Jenner publishes his discovery of vaccination. Smallpox at the time is the leading killer in Western Europe. And he discovers a safe and effective way to overcome that problem. So I think there's a lot leading into the revolutions of the 19th century. But then what basically happens is this maybe you could call it a hunch that some people had, often eccentric scientists, that maybe there were these like tiny little invisible particle-like things called germs were real. And through
I'm sorry to cut you off. What did they think was happening before they realized they were germs? What was the theory?
Well, they don't know that your body's made up of cells. They think your body is a kind of mixture of what they call the four humors. And you live in balance with the external environment. And so they think of infectious disease, they think of disease as imbalance in your four humors, that you're too hot, you're too cold, you're too dry, or you're too wet. This can happen basically from the environment. So it can happen because you're eating or drinking the wrong things, or you're too hot or you're too cold, or the air you breathe is somehow corrupted or putrefied. And so they think of plagues as when the air somehow gets corrupted and everybody whose bodies are made of the humors or breathing the same air are simultaneously affected, thrown out of balance by miasma, as they often call it, atmospheric pollution.
So it's something around us as opposed to something in us.
Yeah, it's something around us that makes the balance of our body get out of whack.
Okay, so what is happening historically as this major discovery is made of germ theory, and then also how to prevent infection?
Well, it really gains a ton of steam in the late 1800s as it becomes, through a series of experiments and then ultimately also microscopes that let people see bacteria, it becomes definitive that many of the diseases that humans suffer are caused by tiny little microbes. And so that has a lot of consequences. Actually, not all of them are sort of new drugs or vaccines. A lot of it is, going back to what we were talking about, new kinds of hygiene. People realize that the cleanliness of your environment really matters. People realize that contagion is important, that, you know, being around somebody who's coughing with tuberculosis is a good way to get tuberculosis. People used to think tuberculosis was sort of a congenital, something and you inherited, not something.
And it just kind of reared its ugly head one day.
Yeah, your body would eventually just sort of start to waste away. It does lead to major improvements in public health. Probably one of the most important things that happens is clean water, is the recognition that there has to be city level provision of sewers to take away waste, and then water treatment to bring people clean water.
I had a professor who said, I always think of this when people talk about the importance of clean water. I had a professor who say, whenever people tell me they want to become doctors because they want to help people, I say, why don't you just become a plumber and take the bad stuff away and bring the good stuff in? I wrote down a few major pandemics and other infectious diseases, and you can kind of pick and choose which ones you think are important. We've talked about COVID. I think we're all surrounded by COVID. Maybe we leave that one out. But I wrote down AIDS. I wrote down the 1918 plague. I wrote down smallpox. And I wrote down COVID. What do you think is important for us to understand here as we think about the way, as you put it, history changes our germs and our germ changes our history?
Well, all of those plagues that you mentioned are very modern diseases, and I'm
biased to the modern. Excuse me, but
that's what I'm getting at, is that we shouldn't imagine that infectious diseases are this sort of like part of our ancient past that, as we become modern, we learn to control, and then everything's great for humans. Actually, as humans multiply and expand in the modern world, there's 1.6 billion people in 1900. There's 8 billion people today. There's more of us. There's going to be more diseases. There's going to be more incentive for germs to adapt to humans. And that's exactly the pattern. Over the course of modern history, new diseases have emerged faster than ever. So we have gained a lot of control, but it's actually even more amazing than it first appears, because we've gained a level of control over a continuously more challenging disease environment. And so as we've grown, smallpox, cholera, the 1918 influenza, polio, AIDS, all of these are are emerging diseases that try and take advantage of our growth and global trade and mobility and urbanism. So it's why COVID-19, to go back to it, because we always go back to it.
Sitting right here.
It wasn't an anomaly. It was sort of, that's the pattern. We were going to face something like this because even in the modern world, these new diseases not just keep emerging, but they probably are emerging faster and faster.
One of the things we've seen with COVID-19 is that it really impacts politics. Have diseases and infectious diseases always impacted politics?
Yeah, I mean, I think there's certainly parallels, although this is one area where I think it's been surprising to me as a historian. Not a lot has surprised me with the unfolding of the pandemic, but just living through this, it's amazing how the polarization of our society has gotten caught up in the response to the disease. My personal opinion is that that's not good or healthy or helpful. We shouldn't try and make vaccination or other ways of controlling the disease political. But it's not unprecedented. I mean, the nature of infectious disease is that it disrupts people's lives. It often impacts societies very differently, and it impacts people within society very differently. And so it affects age groups differently. It affects small business owners very differently from large business owners. And that's inevitably going to be political, right? And so if you're a parent who wants to send their kids to school versus if you're, a person with underlying health conditions or living in a nursing facility, your perception of the risks and perception of what's the right thing to do are going to be very, very different. So it's inevitable that it's political, but it's been surprising to see how polarizing it's been.
1918, was it like that then? I mean, we know there was politics over AIDS, that's for sure.
Yeah, there's politics over AIDS. I think the 1918 influenza was very political. There was some of the same arguments about masks that you see today about how strong non-pharmaceutical intervention lockdowns should be. But my sense is that, I mean, this has been much more polarizing and has fallen really, really strongly along pre-existing cultural, ideological fault lines where people already trust different people, get their news from completely different sources. And it's the polarization of this, I think, is quite different from 1918-19, although a specialist in that period might disagree or have knowledge that I don't, but that's my perception.
You said one thing in the book, that biological warfare is the wild card. And I was like, oh no, don't even tell me that we could start shooting diseases back and forth at one another. What history is there for biological warfare? And is that going to be a main concern as we head into the middle part of the 21st century?
Yeah, I mean, it is an area where there's not a lot of historical precedent, but certainly the weaponization of biological agents is well within the technical capacity of a number of states, and will increasingly be within the technical reach of even non-state actors. And the world is full of bad actors who use power asymmetries to try and disrupt power dynamics or for their own economic leverage. So I think, cybersecurity is maybe an area where we're already seeing a lot more of this, and there's still the potential for much, much more. I think so far we've been somewhat fortunate in that there haven't been major episodes of either state actors or non-state actors deploying really, really serious biological weapons. But I think that's a kind of, to me, underrated feature of COVID-19 is surely there are bad actors out there who have seen how destabilizing an infectious disease can be, and are learning how, our weaknesses. So I think it's another reason that we need to be very much preparing for future threats, pandemics. because there will be natural emerging pandemics. But yeah, I mean, I think it's terrifying to think about, but the weaponization of biological agents is unfortunately something that we need to be readying ourselves for in the future decades.
Germs impact our history impacts our germs. I'm wondering where you see climate change is fitting into this. Is that a way that history could start to impact the germs we have?
I mean, that's a $1 trillion question. There's certainly throughout the past, there's strong correlations between climate anomalies, rapid climate change, and outbreaks of infectious disease. So we know that human health, animal health, pathogens, vectors, and the physical environment are all interrelated. Those are often very complicated networks of relationship that we still don't totally understand. So I think there's a ton of human intelligence, scientists, federal funding that is going into trying to understand what to expect. But just to give an example, if the planet gets warmer, it's going to change the territorial limits of certain mosquitoes that are important disease vectors that are kind of limited to humid regions or tropical regions. And as those go to new places, they can take diseases with them. So it's just one example of how important the climate mechanism can be, but also how complicated it can be. But it's an area where I think you're going to see a lot of progress over the next decade, just because there's a lot of smart people working on it.
I hate to put you on the spot here, especially 5 seconds after you've written a 500-page book that is an epic book, but I wanted to ask, what do you see as being next for you? Where do you see your studies taking you?
Well, I'm a historian. I like to bring the sciences into history. I like to understand how humans relate to the environment. And my favorite parts about writing this book were often the parts where I got into talking about animals, whether it's, cows or rats. And I just love animals. So I think I'm going to do something that explores the relationship between human history and biodiversity, the way we use animals, the way animals shape our world, the impact that we're having on biodiversity and have throughout our past. So it's still very much taking shape. I'm still kind of in the big book hangover phase, but I don't blame you. Clear.
How is everything in Oklahoma? That is a state that I have not been to. I certainly hope to go there one day. What is life like there in Oklahoma? How is it?
I'm a native Okie. I love it. It's an underrated place. It's got a great big city, which is Oklahoma City is a really cool city. It's got everything, and yet still has a very small town feel. It's a very easy place to get around. It's a very friendly state. It's a very diverse state in every way. Like ecologically, we've got mountains and prairies, great outdoors, tons of lakes and hiking and just really gorgeous outdoor scenery. Got an amazing history. It's home to 39 sovereign Indian nations that make it a kind of tapestry culturally that doesn't exist with such richness anywhere. It's kind of the West, it's kind of the South, but not really either. So it's a neat place. It's a very very friendly place, easier to get around and make friends and sort of figure out what there is to do than anywhere I've ever lived. So I love Oklahoma. Its response to COVID has not been super impressive. I have to say, I have to confess that. And it's kind of sad and frustrating to see the inadequacy of our response here. But in general, it's a place that has a lot going for it.
I was at a couple of the games in the NBA Finals in the early 2010s with the Heat and the Thunder. So sorry about that.
Don't.
Right.
Oh, right. So painful. That was one of the best concentrations of pure basketball talent to never really have anything to show for it. To think that
go Thunder. Dr. Kyle Harper, author of Plagues Upon the Earth, Disease and the Course of Human History. Thanks so much for being here with us.
Thanks. Appreciate it. Bye-bye.
Check out the book, his website, kyleharper.net. He's on social media at twitter.com/OklahomaHarper. I want to invite listeners to our Patreon page to ask for your support In keeping the show going, go to patreon.com/AxelBankHistory. We will donate part of your contributions to a charity for children's literacy. And thank you for listening to Axelbank Reports, History and Today, conversations with America's top nonfiction authors and why their books matter right now. Check us out on Facebook, Twitter, and Instagram at Axelbank History. We update those with clips from the show, guest announcements, and book recommendations. See you next time. Thanks.